Okay, this last page is just getting good at identifying the structures, and that's one of my goals for you in biochemistry when you're dealing with all these structures, to be able to say, oh, well, that one looks like a lipid, and that one looks like an amino acid, and this one is a monosaccharide, say. So there's a bunch of structures on this page which look like they might be monosaccharides, and I hope you would realize that these two lower ones don't look like monosaccharides at all because they have two rings. In the cyclic form, a monosaccharide will have just one ring. So we're going to examine these up here and see if any of those are monosaccharides. So in the linear form, this looks like it might be a monosaccharide. I need to have a carbonyl group though. I see I have lots of OHs, that's good, but there's no carbonyl group. And so that one is not a monosaccharide. In the cyclic form, you have to have an oxygen in the ring, and this one does not have that. It does have many OH groups, so that looks like a monosaccharide, but there's no oxygen in the ring, so this is not a monosaccharide. This last one has the oxygen in the ring, and it has many OH groups, so this one is a monosaccharide. Okay, let's look at the other two. These look like they might be disaccharides, but let's look at them a little closer and see if they really are. What we look for each ring. So disaccharides have two rings. Each ring does have an oxygen in the ring, that's good. And then we look for many OH groups, and there's not. This is the missing the OH groups. So this is not a disaccharide. Okay. This one has the oxygens in the two rings, so that looks good. And then it also has lots of OH groups. So this one is our disaccharide. Very good.